Well, hello. Again, bit of spare time, COVID lockdown and all that. Did a little bit more of an update. My videos, I realise, are very disjointed, don't really have a beginning, a middle and an end to them, so I wanted to try and clarify a little bit what I've been doing and why. I have an interest in model engineering, have had since I was a child, going to the local park, looking at 5-inch gauge steam trains going around the track. Years later, I'm a member of that club and embarking on a build, two builds actually, a 45 5-inch gauge and a 7.25 Highlander. Spending more time on the Highlander at the moment, just seems more fun. So, in order to build a steam locomotive, as a lot of you will know who have done so or in the process of doing so, you need castings. Well, strictly speaking, you don't. You could make them all from stock, but that would be a lot of machining and you wouldn't get a lot of the details in. I taught myself how to cast, went through a lot of fails and a lot of success and changed the system a lot from when I first started to where I am now. I haven't really filmed any of my casting simply because I do it all on my own, and when I'm in my safety gear I can't use my mobile, so I can't sort of have one hand free to film, and I've tried various systems of tripods and I managed to cook one phone, which was a costly exercise. It was too near the furnace and didn't like it and died. So I've got the system now to about as good as I can. I use two forms of casting, both of which you can see online for non-ferrous materials. I typically cast in bronze. I use vacuum investment casting, of which there's a number of really good videos online, far better than I could do, done by people with far more experience. It's the same process. You're pulling a vacuum and that helps to pull the molten metal into the tiny apertures and fissures of your final product. In order to cast a component like this, these are for a friend of mine. These are brake blocks and the accompanying brake hangers for his Britannia. He's building at the moment, 7.25 gauge, and he's having great success with it. Everything's coming together nicely. He wanted these cast, first of all because it was easier, and secondly you can get a bit more definition and you can lose the squareness of an engineered component more readily in a casting. And as long as a casting is made well, there should be sufficient machining allowances and all the faces that need machining for you to put into a lathe, a milling machine, or hand file even, to your exact dimensions and drilling out holes where appropriate. So how do I start? In this particular instance, my friend gave me the drawings of the components he wanted as per the drawings supplied by wherever he got them from. I then make a CAD file using Fusion 360. Fusion 360 is a massively powerful program. It's free. You can download it. You can download the student version and you can create amazing 3D files. You can make them move. You can do all manner of really complex stuff that is way beyond my understanding. When I've generated the file using the basics of Fusion, which didn't take me too long to get used to, I generate a pattern. Now a pattern, just in case you're not sure what you're looking at, this pattern here, this plastic thing, is the pattern used to make these brake hangers, and this pattern is the pattern used to make these. Now, where are we in that? So, this pattern is generated on an SLS printer, not a PLA printer. I used PLA, and I'll come back to why I moved away from PLA in the next video. SLS is a more costly print. It's nylon, it's very dense, and it doesn't have the build lines that you get with PLA. Anyone that's done PLA printing knows that you get a build line as the filament is laid down. I'm going to show some components later with those build lines on, and you'll see that the casting is still good. sometimes you're left with debris in the component, which in my view is a fail. That debris is the carbonised PLA. SLS doesn't carbonise like PLA, so you get a much cleaner burnout. However, I don't have an SLS printer. They're huge, great industrial things, but you can get components like this printed by industrial SLS printers online. You send them the file, they give you the price, you pay online, and this turns up in the post. However, if I was to make all the brake blocks from SLS and burn out the SLS, I would get very nice castings, but I would be burning quite costly SLS patterns. So how do I use one SLS pattern to give me sufficient patterns to make the components? Well, the answer is by using silicon mould and then molten wax. This process is only viable if you're making multiple components of one SLS print. If you're not making multiple components, it's probably cost effective, certainly on smaller ones, just to burn out the SLS. It burns out very well with the right temperatures. I'll come on to later videos to explain what I've discovered. SLS burns out better than PLA, gives a nice print. I can generate wax patterns for the cost of the silicone to go around that, £2 or £3, and then wax is very cheap. That wax is probably 10, 15p, 20p at max. So I can make multiple wax patterns from my silicon mould that I've moulded this from in silicon. If you're unsure what silicon moulding is for wax patterns, go online, YouTube, much better videos that I could produce by people in lovely workshops with more space and more knowledge. But I got the basics, and so I've generated what you see here and umpteen others over the last couple of years. SLS to wax to casting, final component. When you look at the castings, you will see that it appears that these are rough. That's the way the light is affecting the surface. With a little bit of wire wool and emery cloth, that comes to a nice smooth finish. That is the effect of the light on the casting, not the build lines. It's actually quite smooth if you see the pencil. So, a set of castings for 7¼ Britannia completed. Some others that I've done for myself. These are buffer stocks for the 45 that I'm building. Haven't got round to machining them up yet, but they're cast with the foot plate and locating holes that can be made fractionally bigger to locate onto the buffer beams. They came out really nicely. These were using PLA. Now you can see the build lines in PLA are much more visible, and you can hear the noise of the pencil going over those grooves. PLA is dirt cheap. You can buy a kilogram of PLA for 20 quid for your 3D printer. Does a good job, doesn't give an amazing finish. That's going to need sandblasting and rubbing down to get that smooth. Then you might be able to lose that, what's left under a couple of coats of paint and an undercoat. 6 of one, half a dozen of another. When I first started casting, I was happy with that, but since I've developed the process, I know how to improve it. Rear cylinder cover for 7¼ Highlander that I'm building. These are, as they come out the investment, with a bit of a wash. That's the oxide, that's the dirt. Again, it's not damage, it's not debris. For people that are unfamiliar with castings, that's actually a good casting that will need just a rub down and a hand finish. That's come out quite nicely. This is one of 4 axle blocks that I have recently finished, or virtually finished, apart from reaming out the centre and putting it in the lathe just to take that face off and make that perfectly circular again. If again you look on here, you see build lines as a result of PLA. They're not that pronounced, it hasn't been blasted, it's just been cleaned up. And certainly if that goes in a lathe, that'll disappear. They only actually go down probably 1/10 or less than a mil, but visually they look worse than they are. That was cast from 2 parts, the bottom and the top. Did a bunch of those. They all came together with a little bit of machining quite nicely. Once they're finished, they're ready to go. So to conclude, casting, certainly casting in bronze, brass, non-ferrous materials, the use of PLA is good. It's cheap. You get the drawbacks that I've mentioned. The use of SLS to wax gives you an amazing finish if you have multiple parts. If you just have a few parts, you can get SLS printed and you can burn that straight out in your ceramic shell or your investment. I use investment casting, vacuum investment for components of this size. For anything like, for instance, that rear cylinder cover there, that's had some machining done on it. Anything of that size, I would use ceramic shell. It's cheaper, it's quicker. It's quicker as in, you know, for multiple components. When you set the tree up, there's more time drying between each layer, but ceramic shell is good for larger components. Ceramic shell doesn't give you the detail as easily as vacuum investment, because the vacuum adds a great benefit to pulling the molten metal into the tiniest parts and removing any air bubbles. So to conclude, that's what I've been doing with casting, and that's why my earlier video showed the furnace and other bits and pieces. My next video is going to show you what we did for iron casting. Iron casting is actually what I started doing first. Had mixed results with it, but overall quite pleasing. And I'm going to do a little video of that next, just to show you where we are with two-part patterns and sand casting. So that will be up next. Stay safe, guys. Keep well.